Hi everybody, this is practice test number 1 for the college trig class. So there are some things that you need to know. So there are 20 questions on this test, and they are not all multiple choice like they were in the college algebra class. So they are a mixture of multiple choice. There is short answer. There is one where you have to check the boxes where you check all that apply. And then there is ones that is a paragraph, and there's usually only one of those on each test. So it's one longer short answer, so a paragraph basically. Okay, this is one version of the practice test that you can find on eCampus. Every time you open up eCampus, it will regenerate a new practice test for you where it changes the numbers and stuff around. So you really need to watch out for that. Now, it is definitely worth doing that on eCampus because the real test, a lot of these questions, some of them are regenerated where the numbers just change. And then there are other questions that are word for word identical to the questions that are on the study guide. So you will really need to read the test. That is definitely one of the things I will tell you because it is so close to the study guide that it's actually very tricky because sometimes the numbers are identical and sometimes they just change the numbers. Okay? Another thing on the test that you really need to watch for is to read how many decimal places it says to round. Okay? Rounding is very important, especially on the short answer. If you don't round the correct number of places, then it's wrong. Or they give you partial credit. So read how many places to round. Wow, I can't spell today. Okay, and unfortunately, like the first question might be round 2 decimal places, and then further down it will say round 3 decimal places. So it constantly changes back and forth the entire time on the test how many places to round. And that gets a little frustrating. Okay, so those are some easy points and tips for you right there. As we go through, I will star the ones that are the most important, and I will also add in some extra material that I feel like you also need to know for the test. Okay, let's start with question number 2, since question number 1 really isn't a question at all. So question number 2. Tell which quadrant the point -4, 3 lies. So I would start with graphing it. So we are over here, and you will need to memorize your quadrants. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So you would pick the one that says quadrant number 2. Okay? This one is a very easy question, and each time you open the test, it will regenerate multiple versions of the test, but I saw this one on the test itself. Alright, question number 3. Consider the point -2, 1. What point is symmetric with respect to the, and it cut off, this should say x-axis. Okay, and unfortunately my printer didn't print that correctly. Alright, so I would graph that point. So we have -2, 1. So that would be up there. We're going to reflect that across the x-axis, so you count how many spaces it's away from the x-axis. So we are 1 space away right there. So we will go 1 space on the opposite. You start your count at the x-axis, so that's 1 space away. So that would be -2, -1. Okay. So I believe the answer choices are on the next page. So you would pick the one that says -2, -1, which is the very first one up here. Okay. Now, if they gave you the exact same coordinate, but they want the y-axis instead, so that was -2, 1 was our original, and if it asks for the y-axis, you would count 1, 2 spaces away from the y-axis. So I would go 1, 2 spaces away, so we would be at +2, +1 if it was the y-axis. Now, if it asked for the origin or the line y equals x, those are basically the same thing. So our dot is right here. What I like to do is I spin my paper upside down, and then I pretend that this is my new x axis, and these are my new y axis. I would list the points, so that would be 2, -1. And then I would turn my paper upside down, and I would be picking the one that says 2, -1 would be my answer choice for that one. Okay, question number 4. Anyone that I star, you better know for the test. Consider the function g of x, and that is equal to x plus 2 divided by x squared minus x. Mark all of the numbers below that must be excluded from the domain of g. So if you remember, to find the domain, you set the denominator equal to 0. And you solve. Okay, so our denominator is x squared minus x equals 0. I need to factor out an x here. So I'm left with x minus 1 equals 0. Set each piece separately equal to 0. So I have x equals 0 from this piece right here. Then I have x minus 1 equals 0. So I would add 1 to both sides. So I get x equals 1. So my two answers that I would pick would be 0 and 1. Okay. All right, now this graph down here for number 5 did not print off very well, so you might have to draw in the numbers like I am going to. Consider the statements about the graph of the cubic polynomial f below. Mark them true or false. So this is number 1. This is 2. Right here is 3. Here is 4. And then at the end is 5. Over here they have like 1 and 2. Okay. On the computer screen itself, since you're taking this on the computer, this will be very easy to see. Okay, so the first question says there's a local maximum at x equals -3. And your two answers are basically true and false. Okay, so I'm looking at -3, where x would be. So that would be over here. And if I look, there's nothing over there. That's false. This would be your max here. Okay, so that one's false. Let's bring up our other questions and kind of set them side by side here so we can see them easier. F is decreasing on the interval 2, 3. So if I look between 2 and 3, which is from here to here, and I look at the graph, it's going down. So this one is true. F has a y-intercept between 1 and 2. So I look over here between 1 and 2. On the y-axis, there is definitely no y-intercept there. So that's false. F has exactly 2 local minima. So local min on here would be this right here, but there's not another dip down, so that's false. Oh, I missed the range one. Oops. Okay, the range of F is negative infinity to infinity. So if you look, the arrows are going in opposite directions, so that's true. So if I were to put arrows on here, one's pointed up, one's pointed down, so that means your range is that. So that one's true. I didn't mean to skip that one. F is decreasing on the interval 3, infinity. So I look from 3 to infinity. So 3 starts here, infinity goes here, and it's going up. So that is false, it's increasing. Okay, F is an even function. Alright, so even, I like to think of my parabola. So one that either opens up or one that opens down. Okay, so they're symmetric about the y-axis. Odd ones would be like your classic cubic functions, because if you would turn your graph upside down on the odd, it would look the same as if you can't see that there. Okay, so if I look upside down, it looks the same as if my paper has not been rotated at all. So that's what odd is. So if I look at my graph here, it's definitely not even, because I see a hump here, there's no hump over here. So it doesn't balance out. So this is false. Okay, a local maximum of 2 exists at 2. So if I look at 2 here and I go up, and that's supposed to be 2, I didn't draw this very well, so that is true. So if I look at that point right there, the y-coordinate there would be 2. A local maximum of 3 exists at negative 0.5. So I look at 3 and I have a min. If it said min, that would be true, but this is false the way it's worded, because that's not a max, that's a min. Okay, f of 3 equals negative 0.5. So if I look at 3, I go down here, and you can't really read it very well on this coordinate. You'll be able to tell a lot better on the computer screen. That is true. Okay. All right, question number 6. Find the coordinates of the center of the circle. So they have x squared plus y squared plus 6x minus 6y plus 14 equals 0. Also find the radius. So what we're going to do is we're going to put the x's together, the y's together, and the number on the opposite side of the equal sign. Okay, so I have x squared, and I'm going to put the other x with it. So plus 6x. I'm going to leave some space so I can complete the square. Plus y squared minus 6y, leave some space to complete the square, equals, and I'm moving the 14 from this side to the other side of the equation, so instead of it being a positive 14, it's going to be a negative 14, because I had to subtract it on both sides. Okay, so to complete our square, you take this number here, we divide it by 2 and we square it, and we add that to both sides. We're going to do the same thing over here, except for instead of being a positive 6 on the top, it'll be a negative 6 on the top. So divide it by 2 and square it, add it on both sides. Okay, move that over so we can see it. Alright, so then you're going to put this and the quantity of that together. So it's going to be x, And you need to ask yourself, what is 6 divided by 2? Well, 6 divided by 2 is 3. We'll put the little 2 from right here, goes on the outside. Plus, we'll put this and this together. So it'll be y, and negative 6 divided by 2 would be negative 3. And then I would probably get out my calculator and calculate what all of that part is. So negative 6 divided by 2 is 3, and 3 squared would be 9. So we're looking at 9 plus 9, which is 18, minus 14, so that would be 4. And you can just type this whole thing in the calculator if you want to. Alright, so for the center, remember you have to switch the signs. So we're switching signs on both of these guys. So it'll be negative 3, comma, positive 3. And the radius, I can guarantee you, and I can just tell by looking at the answers over here, they're going to put 4 down, and it's wrong. You have to square root it. So it's the square root of 4, which is 2. Okay, so our answer is, I guess, the third one down, right here. Okay, question number 7. I saw that one on the test too. A triangle has vertices at the points 1, 1, 4, 1, and 4, 3. Find the area of the triangle. So first thing we're going to do is plot these points. So 1, 1, 4, 1, and 4, 3. And because this is a right triangle, and these sides are straight, this is going to make life easier. So what you want to do is count from this dot to this dot. If it came up that they were diagonally like this, you wouldn't be able to do the count. You'd have to do the distance formula 3 times and figure out which one was the hypotenuse. Alright, but since it's even on here, I know that this is 1, 2, and 3, so this is 3. And I would go up, so this would be 1 and 2, so that's 2. Formula for area of a triangle, 1/2 base times height, so my base and my height would be 3, so 1/2, 3 times 2, well, 3 times 2 is 6, and half of 6 would be 3. So you would put 3 down for your answer. Okay, question 8. 2 remote control car enthusiasts are racing at a circular track. At one point, the red car of one racer is ahead of the blue car of the other one, shown in the picture. What is the distance between the 2 cars? If you know the formula, this is actually a very easy problem. So the formula is S equals R times theta. So S is the arc length. Okay, so that would be like from here to here. So that would be the curve. R is for radius. And theta is your central angle. Okay, so here would be theta, and then the 100 yards would be your radius. So we just have S equals 100 times pi over 4. And so basically all I'm doing is figuring out was 100 divided by 4. So that would be 25 pi. Okay, I think this might have been a multiple choice question. It was. Okay, and then your answers are on this next page. So you would pick the 25 pi at that point right there. Alright, question number 9. Convert the angle 3 pi divided by 9 radians to degrees. I can pretty much guarantee you will have some kind of conversion on your test. If you know the formula, it's really not bad. So your formula is 180 over pi, or it's pi over 180. Just make sure the 2 pi's are diagonal so they cancel each other out. So we have 3 pi over 9. And I know I'm going to use the pi on the bottom because I want the pi's to be diagonally. So we're going to put the 180 on the top. And then what I would do is I would get out my calculator and I would figure out What is 3 times 180? So 3 times 180, that's 540 divided by 9. And it gives me my answer is 60 degrees. So you would put a 60 in there. And you don't put the degree sign or nothing in the test. You would literally just put the 60 in the blank. Okay, question number 10. If the center of the circle is -4, 1, and the point 5, -3 is on the circle, then what is the radius of the circle? Enter your solution, and then here's where you have to read 2 decimal places. So you really have to read what it says, and then the next question on your test would say, instead of 2 decimals, 3 decimal places. And then the next one would say 1 decimal place. So really make sure you read how many decimals you're plugging these things in. All right, so we are just going to do the distance formula, basically. So what we have is -4, 1 would be a dot here. And then we have a point 5, -3. And so basically that's the middle of your circle, and then your circle's going around. Okay, and I don't know exactly how it goes around. So you're finding the distance, basically. Okay, so this would be x2 minus x1 squared plus y2 minus y1 squared. You need to have that distance formula memorized for your test. They will not give that to you. All right, so this is 5 minus -4 squared plus your y-coordinate over here is -3 minus 1 squared. So this is, we're going to change the signs there. So we're really adding them. So 5 plus 4 would be 9. 9 squared would be an 81. And -3 minus 1 would be -4. And -4 squared would be a 16. So then I would add these together. So that gives me 97. And then I would type that in there. Since they want 2 decimal places, you need to follow the rounding rules. So 2 decimal places. If you don't, I think it might take maybe 1 point off. So I look at this 8 right here. And since the 8, 5 and up, you round up. 4 and down stays the same. So since it's an 8, that 4 is going to turn into a 5. So 9.85. Okay. All right. A lot of these I saw on my version of the test. Okay, select true or false for each statement. Sine and secant are reciprocals. That is false. Okay, that would have to be cosecant. Okay, if cos equals 1/2, then sine of x equals 1/2. Okay, so that would be false. You could do a diagram to figure this out, or you could type it in the calculator and figure it out. Let's look at the diagram. I think that's probably the easiest way to explain it. So here's my theta down here. So we would have 1, and then for this to be 1/2 right here, you'd have to do your Pythagorean theorem for sine. So if this was sine, then I would have to do 2 squared would equal 1 squared plus b squared, since 2 would be your hypotenuse. So we're looking at 4 is equal to 1 plus b squared. So b would, I would minus the 1, So we would have 3 would be b, and then we would have to square root it. So this would be the square root of 3. And since this is the square root of 3, for it to be the exact same triangle at the exact same spot, cos wouldn't be 1/2. Cos would be square root 3 over 2. So this is false. Okay, cosine and secant are reciprocals. That is true. If sine of x equals 1/3, then the hypotenuse of the right triangle of the interior angle is 3. So we have sine of x equals 1/3. So I would probably look at a diagram here. So sine of x equals 1/3, so that would be 1 and a 3. Then the hypotenuse of the right angle with the interior angle is 3. On this specific case, that is true. But the problem with this problem is also look at this triangle. Okay, so if I have theta here and I just multiply everything by 2, I have 2 and 6. So if I would do sine of theta here, I would get 2 over 6, which reduces to 1/3. But if I look at the length, it's not 3, it's 6. So that the hypotenuse isn't 3, it's 6. So this is false. Okay, and then of course you could multiply everything by 3, and you could times everything else by different numbers, and again it would still be false. Okay, sine of x equals the cosecant of 90 minus x. That is false. That is just using one of the trig identities. Tan of 90 minus x is equal to the cotan of x. That is true. So you're going to need to memorize all of those. They are in your book. Okay, so this right here may look confusing just because you guys are a lot younger than what we are. When we were older, we learned that this was Sokotoa, and it was an ancient Indian, and this was one of her cultures, and she learned this word as a kid. So she learned that sine was opposite over hypotenuse, cosine was adjacent over hypotenuse, and tangent is opposite over adjacent. So if you look, the trig identity doesn't match with this, so that's false. Okay, and then the last one, sine of 45 is equal to the cos of 45. I would just type those in the calculator if it were me. So sine 45, 0.707, cos 45, 0.707, that's true. Okay, question number 12. Find the distance between 0 and 5 and negative 10 and 5. Approximate with a number accurate to decimal places. That again is just using the distance formula, and we're going to use 2. So this would be negative 10 minus 0 squared plus 5 minus 5 squared. Well, should go a lot quicker this time around. All right, negative 10 minus 0 is negative 10. 10 squared would be 100. 5 minus 5 is 0, so that would be just the square root of 100, which would just be 10. And I saw that one on there too. Okay, question 13. All right, match the function below with their domains and their ranges. I saw one of these on there. It wasn't all 4 of these. It was just kind of like one question, like it gave you just D and it says what's the domain and the range type thing. So you probably, I don't know how they're going to do the grapher. If you get a grapher, it would have to be on the computer screen itself, because you do not get a graphing calculator per se. You get no handhelds, so it's got to be on the computer screen itself. So we're going to do as if you don't have any kind of graphing calculator at all. Okay? So question A, I think, is the most difficult to graph. So we're going to put it over here. What I would do is an XY table. When in doubt, XY table will not stir you wrong. Okay, so we'll start with -3, -2, -1, 0, 1, 2, and 3. Those are always my go-to picks when I'm doing stuff like this. So I would do 1 divide. Make sure you put parentheses around the entire denominator. So we got -3 squared plus 1. Now notice when I type this in the calculator, I put -3 in parentheses also. If you don't, your calculator will lie and say that it's -9 instead of a +9. So just remember you have to do that. Okay, so that gives me 0.1. Okay, and then I'm just going to scoot on over and change it to a 2. 0.2, change it to a -1. 0.5. We'll delete out the negative and put a 0 in the spot, so that gives me 1. We'll change that to a 1. 0.5. 2 is 0.2. And 3 is 0.1. Okay, so we're going to graph this thing. So at 0, we're at 1. At 1, we're at 0.5. At 2, we're at 0.2. At 3, we're at 0.1. And then it just mirrors it on the other side. So we get a graph that looks like this. It doesn't really look like much. Okay, so now we should be able to pick off the domain and the range. So the domain, this is going to keep going on and on. That's going to keep going on and on. It's never going to cross the 0. So it's D, all real numbers. Okay, the range, well, we start from 0, which we never hit, and we go up to 1, so that would be A. Okay, B. Alright, so I'm going to switch over to my erasable pens, because when I do these problems, I always like to erase. So we're looking at 2x, so your y-intercept would be 0. And then we would go up 2 and over 1, up 2 and over 1. So we're looking at a straight line like this, and of course it would continue going down like that. Now we only want the part that's greater than or equal to 1. So we're going to keep this right here, and this is how I always like doing it, and everything below that we're going to erase, because that's all the negative half. So we're just going to keep that half. Okay, and then we're at 2 if we're between 0 and 1. Of course, this would be an open circle. So right here at 2 would be an open circle, and then we would continue on to 1. Technically, that would be an open circle, but it's closed in because right of this equation here. So that's what this graph looks like. It's kind of odd looking. Okay, so the domain of b of x, so we're going to start from 0, and it's going to continue on because this would have an arrow at the end. So 0 to infinity, and 0 is not enclosed, so this would be f. Okay, the range, so it would start here from 2 and go all the way up to infinity, so that would be D. Okay, question number C. And of course, we can do another XY table for C. I probably picked the same points that we did before. -3, -2, -1, 0, 1, 2, and 3. This is your best bet if you don't have access to a graphing calculator. Alright, so we've got the square root of 1 minus -3, and that would be it. Okay, so that gives me 2. Switch that to 2. 1.73. You can't really see my calculator. I'll try to move things around here. Okay, -1, 1.41. Okay, we'll delete that and make that be a 0. So that's 1. Make that be 2. Okay, and then I get domain error. Okay, so it can't go beyond that spot there. So second, I think you can just clear it out. And I believe we're going to get the same error for the rest of them also. Oh, what was it when it was at 1? Oh, that one was 0. And then we got the error for both of these. Okay, so we're going to graph what we have. So at 1, we're at 0. At 0, we're at +1. And we're going to go up to 2. Oh, not yet. 1.41. Oh. Okay, so this spot right here, that was a mistake. That shouldn't be there. -2 would go up a little bit more, and then that will go all the way up to 2. So it's going to look like this. And that little X shouldn't be there. Okay, so the domain of this, well, we are starting at +1 and we're going to -infinity. So -infinity to +1, solid dot, so we should have a bracket, so that would be E. The range would be from 0 and it goes to infinity. 0 is enclosed, so that would be B. All right, and question D. X to the 4th power, that one's easy to graph. You should have that one pretty much memorized. It's just a little bit skinnier version of x squared where it starts at 0. You got a parabola. Okay, so domain of that would be all real numbers, which is D. And yes, you can pick the same answer choices more than once. And the range of this would be 0 to infinity. So that would be B. Okay, question 14, match the graphs with the image and their type. Okay, so this is basically just memorizing the names of the graphs. Okay, so red has the point down there, so that means it's absolute value. So red would be B. I know these aren't really colored on there very well, but you're just going to have to go with what I wrote in. Okay, olive green is this B one that's going from here to over here. So that one would be your radical one, your square root stuff. So that was D. C is turquoise. I'm guessing turquoise is the same thing as teal. Okay, so that would be C, so that goes from here and then like that. So that one would be your 1 over x equation. So that would be your rational function, which would be A. Your equation for this green one would have been square root of x. Okay, D is navy, so that's the one that's going upside down. U, parabola. So that would be -x squared. So another word for parabola would be C quadratic. And the dark green, where is the dark green? Oh, here we go, right here. So it's going straight line, so that would be linear, which would be E. Okay, so that should be a relatively easy question on your test if you get that. 16, what is the length of the hypotenuse for the given triangle? You will need to memorize a squared plus b squared equals c squared. This should be fairly easy. So it doesn't matter what order you put the a and the b in. So just know that diagonal from the 90 has to be your c, which is the hypotenuse. So we have 4 squared plus 3 squared equals c squared. So 4 squared plus 3 squared, so this is 16 plus 9, that's 25, equals c squared. Square root that thing, and you get c equals 5. So that would be right there. Okay, question 16. What is another name for the longest side of the right triangle? That is hypotenuse. Super easy. Unfortunately, I did not see it on my version of the test. Okay, some other things that I would memorize for your test that would be helpful. Look up the formula for Celsius and Fahrenheit and have those equations memorized. Okay, so just look those up on Google, figure out what they are, memorize those. Okay, another one. I'm just starting to write these questions in, okay? Okay, so the question will just have a triangle already on there. So the question is, what is the cos of theta? So that should be fairly easy. I would put my man right here. Diagonal from my man is the opposite. Okay, diagonal from the 90 is your hypotenuse. Beside your man would be adjacent. Okay, cos is the same thing as adjacent over the hypotenuse. So you would pick 4 over 5. Okay, so you will see questions like that on there. Okay, here's another diagram that I'm going to draw in. And just bear with me, this is a very rough diagram, but just do the best you can. And I didn't number very well when I drew this, so this is going to start -3. And they're not really counting that evenly, but this is 1, this is 2. So we'll put our dot right here. This is our dot 1, 1. Here's 2. 2 is our dot. Okay. And then it just kind of goes down and shoots up through that dot right there. Okay, and down here at the bottom would be -2, where that should cross through. Okay, so that's the rough sketch. And then here are the 2 types of questions that you could see on the test that would go, so it'd give you the graph and then it would ask you these kinds of questions. So what is f of x equaling 1? So they want to know what is the x. So basically, what is x? That's probably not worded really good with proper English, but basically, when it's written like this, you're going to look at where 1 is. So you can see there's 2 answers. So you would go across up 1 when the 1's on this side, and you find your 1 on the y-axis, and you say, okay, it's right here. Go drop down to your x number and read your x numbers. So that would be -5. And then your other one, you would come over here and see there's the dot at 1, drop down, and it's also at 1. Okay? All right, same picture, different question. What is f of negative 3 equal to? Okay, you see how it's worded differently? Here the number was after the equals. Here now the number's plugged in for the x. Okay, so what you would do is you would look at your negative 3 on the x, and you would drop down and read what your answer would be. And I meant to have this go over here, but I didn't really do that very well, so we'll have to, so you would look at your graph, go over and read where your answer would be. So I would probably say that looks like negative 1.5 to me, because I bet negative 1 would be right here. Okay. But that's what you would do. You would find the x, drop down to the graph, then read it off of the y coordinates. So you just read it off a little bit different than the previous one. Okay, another question you might see is, what's the inverse of y equals x minus 3? So if you get a question that asks about the inverses, what you need to do is you need to switch the x and the y values. Okay, so instead of this saying y equals x minus 3, we're going to rewrite it as x equals y minus 3. Okay, so we're going to add 3 to both sides. Add 3 to both sides. You solve for y. I probably should have added that on there. Okay, so I get x plus 3 equals y, and this would be your inverse. Okay. All right, and then the last type of question you would see there is a short answer question. Okay, and here's one that was similar to what they wrote. It's not identical to what they wrote. So it says, discuss the algebraic and geometric ways to find slope. Contrast the two ways of thinking by giving a geometric description of slope and then giving an algebraic description of slope. So algebraic basically means equations and things like that. So I would say if I was going to find slope, I would use the slope formula, and then I would give an example. So I would give 2 coordinates, and then I would say you do y1 minus y2 on the top divided by x1 minus x2 on the bottom, and I would show my example and then plug it in and get the answer. Now, geometric means that you're looking at the graphs of things. So I would say something like, to find the slope geometrically, I would use the graph, and I would count the rise over the run. So if I had a graph, I would count up and then count over to the right, and that would be my slope. So I hope that this helps you. Good luck on your first exam, and have a nice day.